A little bit of a break, and then more swell is on the way. I'm Mark Sponsler, and welcome to the Stormsurf Videos Surf Forecast for the week starting Sunday, January 16th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, real data for outdoor people, all the time, no hype.
Looking at significant wave heights in the North Pacific Ocean, we see a gale kind of ill-formed, generating 22-foot seas a little bit west of the dateline and pretty well at Hawaii, and that likely is going to generate some swell. All right, let's get into the details. As usual, we'll start by looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales, and when they form, help direct their track. We're looking for a dip in the jet, sort of like right there. What that helps do is create a counterclockwise flow aloft and down at the ocean's surface. That's the hallmark of low pressure. Of course, low pressure, if it's strong enough, generates winds. Winds, if they're strong enough, generate seas. Seas, as they radiate away from the fetch area, eventually turn into swell. Swell, when it hits your beach, turns into surf. So, the origins of all swell-producing storms really are the jet stream. And right now, we have a very good-looking jet stream. Winds, the jets pushing consolidate off of Japan to a spot almost due north of Hawaii, with pockets of wind energy up to 190 knots. That's pretty strong, and starting to dig out a little bit of a trough here, supportive of low-pressure development, but nothing too exceptional. But given the wind speeds, even though the trough isn't particularly well formed, it's what you call a shallow trough, it doesn't dig deep, that in turn should generate some sort of a gale, which should result in some sort of swell. Now, the other interesting point, and there's been some discussion about it on the forums, is this split in the jet stream right here. Northern branch pushing up into Alaska, southern branch pushing south. Typically in a split jet stream flow, you have high pressure, and high pressure completely blocks out any rainfall, precipitation, snow, anything like that. And it tends to set up, beautiful conditions for surfing in California, but no weather at all. So it's sort of a double-edged sword. We're in a good situation to get swell and surf and clean conditions in California. Maybe not quite so much for Hawaii because the jet right now is falling south over it. But no hope for precipitation, at least immediately. Let's look into the future. So get into Monday, jet starts building with winds to 200 knots. That's pretty strong, pushing off Japan. The trough, or the semi-trough, as you will, continues. Winds build to 210 knots. That's quite strong, pushing off Japan. Same sort of configuration. The split jet holds in the east. Wednesday, really no change at all. If anything, the trough, or the weak trough that's there, pretty much kind of fades out. Still supportive of gale development. And as we get into Friday even, more of the same, 180, 170 knot winds. The split point holding right at around 155 or 150 west, and not budging an inch. All this, we believe, is being driven by the active phase of the MJO, and we'll get into that in the later part of the discussion. So, great for storm production, but again, really worried about precip into California. We're at, about 75% of normal for the whole year, but we need to top off the tank with that last 25%, and that's what we're a little concerned about at the moment. Saturday, no real change. Sunday, notice the jet starts fading a little bit here in the west. So the question is this the sign of something where the jet sort of falls apart, the storm machine, at least from a swell production standpoint, starts fading, and then the jet starts splitting? If that happens, if less energy goes into the jet, the split point will retrograde back here, and then you get the jet. Notice how it pushes up here north and then falls south over the interior U.S. If the split point retrogrades back to, say, the dateline or so, then that north falling motion would be down the U.S. west coast, and then that would set us up back for what we had back in the Christmas time, and then again back in October, what's known as backdoor fronts. Cold air pushing down, maybe picking up some moisture off the Pacific, and then making for good precipitation down all the Sierra and the whole Cascade, the Northwest Pacific Range. Still, a bit too early to start speculating on that, but that is what we're trying to keep our eyes open for. All right, let's go take a look down at the surface. Surface level pressure, surface level winds. As we saw before, there is some sort of a broad, weak trough here supporting low pressure development. 968 millibar low here in the northwestern, I'll say it over the northern dateline region, generating varying degrees of 30, maybe 35 knot fetch, but not consolidated, not particularly organized. Now, as we get into Monday, that fetch builds a little, 30, 35, almost 40 knots in one pocket, all aimed really well at Hawaii. Same deal pretty much as we get into, actually in Tuesday, things fade out a little bit, and that fetch is gone. But a new low develops, or maybe a secondary fetch, a little bit stronger with 35, 40, 45 knot winds right here, the West Pacific. That pushes across. There's a little tiny pocket. You can't even see it there. 55 knot winds. So we get into Wednesday, pushing over the dateline with 50 knot winds Wednesday night, continuing into Thursday morning, fading from 45 knots, and then fading out more as we get into Friday while it pushes over the dateline with yet another low or gale or storm, if you will, with 50 knot winds approaching the dateline, pushing over the dateline with 45 to 50 knot winds as we get in Friday night, lifting northeast on Saturday and slowly fading out as it pushes up over the eastern Aleutians. And that's 180 hours out. And then it sort of looks like another break sets up, sort of like almost where we are right now. So let's take a look at the effect of those winds on the ocean surface. Now, we've had a good series of storms and swells. I mean, it's been pretty much nonstop here in Northern California this past week. Even yesterday, sneaker solid waves over 10 foot, pushing 15 foot at times were coming in. Today, still a good solid well overhead surf, pushing double overhead, but definitely things are going to settle down a little bit because there's not been anything any broad system in the past day or two, and the focus now becomes this gale here off in the West Pacific. And you notice it's very fragmented, 20, 22 foot seas as we get into Monday. Still, maybe a little pocket of 24-foot seas. But then we get into Tuesday morning and it pretty much all vaporizes. You can see right here seas, significant wave heights from that gale pushing towards the Hawaiian Islands. And it'll eventually reach into California, and not particularly like impressive size surf or swell or anything like that, but something rideable, more so for the Hawaiian Islands. So you get into Tuesday night, pushing into Wednesday, new system, we saw that developing here over the dateline, seas building, not looking as good right now as it did earlier today. What was that, about 35-foot seas, the highest seas over this whole domain here, and holding as we get, there we go, Thursday morning up to 38 feet and then 37 feet. I mean, that's pretty decent. Not over a huge area, but solid. Aimed both at the Hawaiian Islands, U.S. West Coast. You can again see the swell front approaching Hawaii right there. And then the new system builds behind that with 33-foot seas, something like that, lifting northeast. And this is on Saturday night. And then after that, that all just kind of fades out. We're 180 hours out, and you get the distinct impression that the storm cycle might be over. A quick look at local winds here, mainly for California and Hawaiian Islands. I mean, a light wind regime is in place for both locations right now. I mean, this split jet stream flow, high pressure loft has just set up endless days of light to medium offshore winds in California. And the wind situation has been pretty good in the Hawaiian Islands as well. No major change coming with no cold fronts or anything really forecast for the U.S. West Coast. We'll just play this out. You get this sort of a southeast flows. We're into Tuesday for Hawaii, and light northwest winds off the U.S. West Coast. Thursday, a little bit of Wednesday, a little bit of northwest winds off of northern California, mainly off the coast other than Cape Mendocino, 15 knots. Trades pretty much continue for the Hawaiian Islands. Wednesday into Thursday, a little bit more of that fetch, that north fetch off Cape Mendocino, but there's no real swell expected either then, so it's kind of like, well, it doesn't really matter, right? So we get into Friday. The expectation is some of this is going to start settling out for the U.S. West Coast. Still a light wind regime for Hawaii. As we get into Saturday, here come the light winds offshores again. This cutoff low off here, kind of interesting. Not really expected to do anything, but it's there nonetheless. As we get into Sunday, again, offshores for California, a little bit of a northeast flow for the Hawaiian Islands attributable to this cutoff low, and we're 180 hours out there. This might be a bit of an issue for Hawaii. Northeast winds, protected breaks will be okay, but U.S. West Coast, pretty much a light flow, so no major weather systems forecast. And as expected, no snow forecast. We're just using Squaw Valley. Olympic Valley here is the proxy for the whole Sierra because it's further north. And if it isn't getting it anywhere south of there, probably isn't getting anything. Snow levels, well, for the next couple of days, somewhere just above the base of Squaw or the freezing level. Not that it really matters. And then actually pretty high for this time of year, up at 10,500 feet, up to peaks up to 12,000 after that. So really no sign of winter. We're back into that like Indian summer pattern for now, courtesy of the active phase of the MJO not being quite strong enough to just push the jet and let it roar into the California coast, just stuck there north of Hawaii. Just a real quick look at the snow forecast. The U.S.-Canada border right there. Vancouver in that area. Whistler up in there. A little bit of snow maybe as we get into Monday. And continuing perhaps into Tuesday. Another little pulse on Wednesday into Thursday. But really, and a little bit here into Jackson Hole in that area, but no significant storms blasting into the coast. And then when we get into Friday, things really dry out, and we're just blasting through this because there's literally nothing on the charts. There we go. So a little bit up north, and then nothing. This is not unexpected, pretty typical of this split pattern over the U.S. West Coast. High pressure over the Great Basin, that's right in here. That's what drives it's a clockwise flow along high pressure. That drives the offshore flow along California. And, beautiful, nice weather. Not great for precipitation or skiing, but provides a great canvas for when swell hits the U.S. West Coast. All right, let's go take a look long-term. What's going on with the Madden-Jullian Oscillation and La Nina, the ENSO, El Nino Southern Oscillation. As usual, we're looking for signs of the active phase of the MJO, the Madden-Jullian Oscillation. It's this periodic weather oscillation that rotates around the planet on the equator, moving from west to east. There's two phases, the active phase and the inactive phase. The active phase is on one side of the planet. The inactive phase on the other. They rotate around like that from west to east. The active phase is effectively a low pressure system, and of course low pressure generates winds and also generates precipitation and also generates clouds. The inactive phase, the exact opposite. It's a high pressure system, clear skies, no precip, and what it does is it enhances trades where the active phase suppresses trade winds. That's very important because trades in the West Pacific, or what happens here in the far West Pacific, the active phase will suppress trade winds and impart energy to the jet stream, feeding the storm track. Right now, we're in a pretty active storm track. The jet stream is strong over the West Pacific. It looks like the active phase is in play. So we're looking for evidence of that. So we start by looking at trade winds across the Pacific. This is data from the TAO buoy array, a series of buoys strung across the equator in the Pacific Ocean, used for monitoring El Nino, but also can help us monitor or get a rough idea what's going on with the Madden-Jullian Oscillation. This is the East Pacific here. This is the West Pacific here. There's the equator, 180, That's the date line. That's New Guinea there. What we call the Kelvin wave generation here, the West Pacific. That's the important region. When the active phase moves over there, that's where it imparts all its energy to the jet stream. That's also where, if the trades are reversed, it can take warm water that's typically pulled up here, start pushing it off to the east in the form of a Kelvin wave. It's a ball of warm water that travels under the equator the whole way across the Pacific, and then eventually erupts off of Ecuador and could create a pool of warm water there. If you get successive active phases of the MJO and they're strong enough, they create successive Kelvin waves, and that in turn can help usher in, or at least be a signal that El Nino is starting. All right, so we're looking at winds in the East Pacific. We're just looking at the arrows, pretty strong out of the east. Over the Central Pacific, pretty strong out of the east. Over the West Pacific Kelvin wave generation area, pretty strong out of the east. They were not this strong 3 or 4 or 5 days ago, so they're starting to build. But it is not the actual wind speeds, it's the anomalies, differences from normal for this time of year. These strong east winds here, they're a little bit stronger than normal because you see the arrows still out of the east. Over the Central Pacific, though, yeah, that's pretty much normal. You see basically no arrows, nothing going east or west, so that's normal. In the Kelvin wave generation area, a little bit stronger out of the east than normal, suggesting that if we had an active phase, which we did, it appears to be fading a little bit. Now remember, in the jet stream chart, a week from now, the jet stream starts losing energy. We suspect that is going to be tied, or is tied, to the fading active phase of the MJO in the West Pacific. A quick look at near surface winds for the past 7 days. Chart's kind of busy, but there is South America, Chile, Peru, Central America. 0 is the equator. There is the Philippines, New Guinea there, 180 is the date line. So the area we're interested in is right here. And you look at the arrows, or they've color-coded it too here. So yellows, orange are westerly anomalies. So that would suggest the active phase of the MJO. That was on January 10th. Same thing on the 11th. Same thing on the 12th. Those winds trades, and it's just 5 degrees north of and south of the equator. It's not way up in here that we're interested in. Just this tiny little sliver right in here. And you'd think that's hard to believe, that a tiny little area of the ocean surface, or the interface between the ocean and the atmosphere, would make a difference globally on what's going on, but it does. And you see, as we got into the 14th of January, those westerly anomalies fading even more. Here's the forecast going out 1 week. I think this is the GFS model. Oh, there you go. GIN GFS operational forecast. So what we're looking at is the whole plan on one chart. The date line runs right up the middle. The area we're interested in, again, is what we call the Kelvin wave generation area, that West Pacific. So the far West Pacific starts about 135 east. So right there, you go right up the middle of the chart there. Okay, and the Kelvin wave generation area ends about 170 west right there. The yellows and reds are westerly anomalies, generally synonymous with the active phase of the MJO. Blues are easterly anomalies, synonymous with the inactive phase of the MJO. What you see right here, this is what's happened in the past. A pretty big, almost, I'll call it a westerly wind burst. This bar right here, that was a data outage at the data center, so just sort of ignore it. But you can see there was a westerly wind burst right here. That was probably the peak of the active phase of the MJO around, right after Christmas, at Christmas into January 1st, and beyond that, it actually went for 2 weeks, we'll say. That's pretty good. Not a huge westerly wind burst. Here we are today. You see easterly anomalies in the Kelvin wave generation area, and forecast building as we get into the next week, probably suggestive of the inactive phase of the MJO setting up. So this would be maybe a Kelvin wave being produced. This and stormy weather and energy feeding the jet stream. Down here, this starts looking like the jet stream losing energy, the storm track fading, and the jet stream splitting further back towards the date line. But the silver lining in that is maybe, just maybe, it will set us up for that backdoor front machine again, and precip will start coming back into California. Next up, outgoing long wave radiation. That's fancy words for cloud cover. Again, we said the active phase of the MJO is like low pressure. Well, low pressure generates clouds. The inactive phase, high pressure, it doesn't support cloud cover. So the blues are areas that are cloudier than normal, and this is a forecast model. Oh, and let's get oriented here. So 4 different panels, 5 days each panel. South America there, Central America, Hawaii, Ecuador, the equator right there, dateline right there, Kelvin wave generation area right there. That's the area you're interested in. The blue, cloudy, probably the late fading stages of the active phase of the MJO, moving almost east of the Kelvin wave generation area. It ends at about 170 west right there. So right here's our box. And the inactive phase over the maritime continent, Bali, that whole area, starting to move to the east 5 days out, filling the Kelvin wave generation area 10 days from now. This is a statistic model, and then continuing 15 days from now. The dynamic model sort of, we'll keep both of them in here, paints a little bit of a different picture. 5 days from now, no MJO activity at all. Same thing on 10 days. And then 15 days from now, 2 weeks from now, maybe a weaker inactive phase of the MJO setting up in the West Pacific. So the statistic model here, the dynamic model here, both suggest we're moving towards the inactive phase of the MJO. The question is, one says stronger, the other says pretty weak. Maybe it's 6 of one, half dozen of another. It's still inactive phase, but preferably not a strong one. That's what I'd like to see. Phase diagrams for the same two models. Just a deeper dive. Statistic model here, dynamic model here. What are we looking at? The heavy dot is where the active phase of the MJO is. Okay, and the MJO moves from west to east. So this is sort of like a chart or a map. We're plotting the active phase of the MJO as it moves around the planet from west to east, from the Indian Ocean to the maritime continent, over the West Pacific to the East Pacific, under the United States, across the Atlantic, over Africa, back to the Indian Ocean. Right now, the active phase of the MJO is looking to be, I'll say, in the Atlantic somewhere, maybe the Eastern Atlantic. The further away the dot is from this circle, the stronger it is. So a very weak active phase. You can see where the active phase has been. This was the 7th of December. Purple was all the days in December. It's just been noodling around in the West and East Pacific. And then in January here, you see it starting to crash, moving east. And 2 weeks from now, the statistic model suggests the active phase in the Indian Ocean very weak and ill-defined. The dynamic model, even a little bit less optimistic, suggesting the active phase is even weaker than it is here in the dynamic model, somewhere over the Atlantic, and just noodling around there for 2 weeks at all. So the net result here is these two models are suggesting no active phase of any consequence in the Pacific for the next 2 weeks. Next up, areas favorable for precipitation in the upper atmosphere. 8 different panels here, 5 days each panel. South America, Central America, the equator right there, 0. Dateline roughly there. New Guinea there. Kelvin wave generation area right here. Greens, favorable for precipitation. So active phase of the MJO. This suggests the active phase sort of plotting its way across the Pacific, and by the end of January, it's pretty much out of the picture. Here comes the inactive phase. You can just watch it making its way across the planet, pretty much from the end of January into about the end of February. The inactive phase does its thing. That would be a big window to maybe go focus on work and not expect so much from the ocean. And then as we get into the end of February, it looks like the active phase trying to push into the Pacific again. All right, so let's go look out at a month, and this is at 850 millibars, pretty close to the surface, up about 4,700 feet. Here's the forecast. Whole planet on one chart. Dateline runs right up the middle here. Kelvin wave generation area like before, pretty much in this area. You can go up here. Clearly you can see, and the solid black line is the active phase of the MJO, and it's sort of broken up in pieces here. But you can see basically you connect all this, and this is the active phase moving from the maritime continent in late November the whole way almost across the Pacific by the end of January. Reds are westerly anomalies, pretty strong westerly anomalies. These red little circle-y things here, those are actual tropical systems. the active phase of the MJO is pretty good. Because it's low pressure and because it creates westerly anomalies, great for setting up hurricanes or typhoons or whatever, or tropical systems. So you can see they're mapped on here as well. Pretty nifty chart, really. And you see westerly anomalies continuing into January 15th, that's today, and maybe even continuing on into about the end of January, something like that, when the active phase of the MJO starts moving south of California, pretty much out of the picture. The black dotted contour here, weak inactive phase of the MJO, it starts moving into the Pacific, about January 20th or so, so a couple days from now. And the blues, easterly anomalies start setting up. That's clear skies, inactive phase of the MJO, and like the other charts, pretty much suggesting that whatever run of swell we're on within, this is a 1 week period, that's 2 weeks, so probably within about a week, week and a half, likely that's all going to come to an end. So plan your surf sessions accordingly. So then, if going out a month isn't enough of a stretch, let's go out 3 months. Same sort of chart, whole planet on one chart. Oops. Here, we'll do it this way. All right, we'll layer it up a little bit at a time rather than just show you the whole convoluted mess. All right, so past performances down here. The date line runs right up the middle. Kelvin wave generation area from 135 east, so right there, to about 170 west, right up there. This you can see clearly. The yellow's westerly anomalies. So this is back in November. You see westerly anomalies. Pretty strong westerly wind burst right here in the late December, early January time frame. And now here's what we're coming into. Looks like easterly anomalies starting about January 24th. One would guess this is the inactive phase of the MJO. But by the end of February, it pretty much fades out and a light westerly wind pattern sets up. So one would guess this would be the next active phase of the MJO, somewhere in around the March time frame. Let's check our map reading skills or chart reading skills. And sure enough, here we go. The solid red contour is the active phase of the MJO. This is the one that's pretty much all but gone right now. There's the westerly anomalies associated with it. The dotted contour here, inactive phase of the MJO, but not a particularly strong one, especially compared to ones of the past. This is kind of a good sign. It maybe gives us hope that the La Nina pattern that we've been in for 2 years is starting to fade. You can see easterly anomalies still forecast from about January 24th into maybe the end of February, February 25th, something like that. But then the active phase of the MJO shows up again. Light westerly anomalies filling the Kelvin wave generation area. And even after the active phase fades after that, westerly anomalies continue. The past 2 years, we've been lucky to have an active phase of the MJO, one that produces any kind of westerly anomalies. So between this one, this is the first real active phase we've had since last July, I think, something like that. And it looks like we're going to have another. So basically our whole winter, though, is going to consist of 2 active phases of the MJO. And once you get into the March time frame, the atmosphere is already starting to do the seasonal change thing. This probably won't have as much effect as we'd like to have. So this is whatever's happening in the next week or so, that's probably our last shot at any meaningful swell for the winter. Hard to believe, but that's where we're at. All right, low pass filter. Let's overlay that. Here we go. The dotted contour. What is this? This is a high pressure bias. The black solid line, a low pressure bias. This is the La Nina El Nino indicator. Right now, we've had high pressure bias over the date line for 2 years now. The good news here, it's slowly moving off to the east. Should be out of the Kelvin wave generation area as we get into late March, early April. That's good news. The low pressure bias is to slowly be building over the Kelvin wave generation area, maybe late March, something like that. This model always teases, and then it moves. What happens in actuality is slower than what it forecasts. But still, this is good news. This sets us up probably for next year, next fall, next winter, suggesting maybe a return to a more normal pattern. All right, enough MJO talk. Let's go talk El Nino, La Nina. So the main components of El Nino, La Nina are water temperatures in the Pacific and then changes in the jet stream aloft. We won't be able to see that, but we'll get some clues. First off, subsurface ocean temperatures. Data from the TAO buoy array. Again, those buoys strung across the equator. These are the anchor lines on the buoys right there. X's are sensors on the anchor lines. They collect data. They beam it up via satellite to a central processing facility, run that data through a model, and you get a profile of temperatures down in the ocean, down 100, 200, 300 meters. It's really down about 150 meters that we're interested in. But what's that, about 450 feet? Okay, and what you see is then these temperatures are in centigrade. The 29-degree isotherm, that's pretty warm water. It wasn't even on the chart 2 or 3 months ago and hadn't been for a year or two. It's showing up, and it's making progress to east at, what is that, about 176 east, almost to the date line. The 28-degree isotherm moving to the east to 175 west. Not moving fast, but it's moving. The 24-degree isotherm, well, it's been hanging around 125, something like that. It actually went back a little bit. Now this week it's at 135 west. But suggesting that there's warm water here starting to push off to the east a little bit. Maybe a Kelvin wave. But it's not the actual temperatures. It's the anomalies. Again, anomalies. Differences from normal for this time of year. Clear, obvious Kelvin wave developing here with 4-degree centigrade anomalies pushing off to the east. I mean, this ball of warm water was held back at somewhere like 170 or 165 west, like over here, for months and months. You can see it making progress, and you can see, according to this data, minus 2-degree temperatures in the East Pacific. This is the far East Pacific here. They were fading. They were like minus 3 or 4 degrees last week, continuing to fade, moving off to the east, while the warm water Kelvin wave generated from that westerly wind burst, generated from the active phase of the MJO in December and early January. That's what's setting this warm water in motion. The hope is that it's going to push the whole way across the Pacific. And notice it's not on the surface. It's down at depth, 150 meters down. But it'll go the whole way across the Pacific. It'll take probably another 2 months from where it is now, eventually erupt off of Ecuador. Now, that'll warm water temperatures here, and maybe we're not saying that's going to usher in El Nino, but what it might do is just finally put the stake in the heart of La Nina. Here's another model, saying a little bit higher res model, painting the exact same picture. Warm waters now to 140 west. They were back, making it no further than about 155 west over Christmas. So slow, steady western progress. The cooler anomalies, not as cold as they were. We got a little patch of warming even off of Ecuador. And they're getting pushed to the surface and hopefully out of the way. Sea level height anomalies. Here, see if we can back this off just a little bit. Oh, probably not. One more shot. There we go. Okay, sea level height anomalies. All right, so this is kind of a hard chart to read, but Chile, Peru, Central America, Hawaii right there, equator there, dateline there, Philippines there, New Guinea right there. All right, this is not showing temperatures. This is showing the height of the ocean and the sphere of the ocean. You take the waves out, take the wind waves out, even the tides, even the tsunamis, and you just look at the sphere. Is the sphere of the ocean higher or lower than normal? If it's lower than normal, like it is here, minus 5, 10, 15 centimeters off of Ecuador and Peru, that suggests that there's colder water at depth. Colder water contracts, creates a divot on the ocean surface. You see warm water in the West Pacific here, plus 10, 15 centimeter anomalies. Warm water expands, it'll create a bump on the ocean surface. Of course, you also have nuking trades over here. They'll scoop out some of this water, also contributing to the negative anomalies, and push it up here. So you got a ball of warm water here held by strong trades, but at some point the trades will collapse, especially if you get a Kelvin wave, warm water, and it's at, where did we say, about 145 or something like that. It's under here right now, and this chart sort of supports that. Once it erupts over here, these anomalies will disappear, and that should also make the trade slacken, and then that pretty much is how La Nina collapses. So this chart really tells the picture. I like this one a lot. This is the West Pacific here, East Pacific here. You're going back in time a year. The reds are warmer than the normal temperatures. The blues colder than normal temperatures. Here is the La Nina, and if you scrolled up here, you'd see a big dark blue circle up here from October, not just 3 months ago, but a year and 3 months ago. It faded back in March. Same sort of thing that's going on right now. Active phase of the MJO created 1 Kelvin wave right here. Another Kelvin wave, warm water making it the whole way across the Pacific. Little remnants of a third, and then it all faded out. La Nina came back stronger than what it was before. And now here we go. But now we're in December. So we got an active phase of the MJO. You can see the Kelvin wave slowly, and we're watching this every day. It just ticks about another degree off to the east, making its way across. We've said this before. Typically when you get these, we'll say, bigger changes in the atmosphere, like moving from El Nino to La Nina, if they're bigger changes, they tend to happen in the January-February time frame. Maybe this is that. I still don't think we're moving towards El Nino. There's not enough warm water over here to really support that, but we'll see. It's probably towards a neutral phase, but let's go look at some more data. All right, so what's going on at the ocean surface? Still clearly a La Nina signature. South America here, Chile there, Peru, Central America, Hawaiian Islands, the equator right about there. It's doubled, so I mean we're stitching together some images here. It's not a perfect stitch, but you see much colder than normal water off of Ecuador, almost out to the dateline on the equator. Warm water almost the whole way across the Pacific. We'll get a backed off view here in a minute. But what I want to show you here is right in here. Look at this. This is warmer than normal water building off of Chile. Now things have been much colder, but lately in the past week or two, warming building here, and all this light blue in here suggests some sort of a warming pattern going on. We know there's a cool pool, a pocket of really cold water trying to get pushed to the surface. There's a Kelvin wave somewhere. Well, where are we? Right about 145, somewhere here. So there's a Kelvin wave, warm water, underneath the ocean, pushing this way, squeezing that cold water at depth up to the surface. And here it is on the surface, and it gets caught by the trades, pushed off to the east. Here we go. Here's the trend for the past 7 days. Much warming going on. This has been going on for almost 2 weeks now. A lot of warming off of Peru, Chile right here. A little bit of warming. The main area, though, that you're really interested in is right here on the equator, but sometimes this contributes to the flow. I mean, you got high pressure here, right, rotating counterclockwise in the southern hemi. It drives trades and temperatures up this way and then out along the equator. In the northern hemi, you have high pressure here doing the exact opposite thing. They converge somewhere roughly here on the equator. So we still have a little bit of cooling. This is that deep water cooling getting squeezed to the surface by the incoming Kelvin wave, but also little pockets of warming. And then here's the high-res overview. And what you can't see in this picture, but if you follow this picture day after day, see this lighter blue stuff just all in here, suggesting what was really cold water getting warmer. You see actual warming building up along Chile, almost up into Peru now, also trying to work its way down from Central America down into Ecuador. It's really just this area from the Galapagos out to a point about 140 west, not even south of Hawaii hardly. That's where all the cooling is. The entire North Pacific is warmer than normal for this time of year. These are anomalies. These aren't actual temperatures. This is just relative to normal for this time of year. Pretty warm in the North Pacific. Over here, pretty warm. Look at the Indian Ocean, quite warm, but the low pressure bias has been sitting right over here for 2 or 3 years. Now the other little thing is, you look at warm water in the West Pacific, and we're kind of the opinion that not all the warm water reservoir that would support the development of an El Nino is right here. It's all baking in these islands, and so if you get an active phase of the MJO pushing over the maritime continent, it'll squeeze warm water up and out through here and up through these little channels. I mean, we've actually done some research on it. It's possible, not sure that there is enough here to support some sort of an El Nino. And again, I don't think that's going to happen. But pretty good volume of warm water in this area if trades were to traverse, if a decent active phase of the MJO were to set up. Temperatures in the Nino 1.2 region is the area right there off of Ecuador to the Galapagos and down almost to Peru. Warming steadily, we saw that on the other chart. Still pretty cold. 919 thousandths of a degree below normal, so almost 1 degree below normal. But certainly warmer. It's the trend that's really kind of important. Warming since, well, for the whole fall, we're finally up to something better than freezing cold. Still not great, still indicative of La Nina, but it's actually the Nino 3.4 index. This is the area on the equator from a point south of California out to about the dateline. Temperature's been hovering around about 0.8 of a degree below normal, dipping below 1 degree there right at the beginning of the year. Today, 781 thousandths of a degree below normal, 3/4 of a degree below normal. The La Nina threshold, half a degree below normal for 5 consecutive months. We've certainly beat that many times over. We want to see these temperatures get above the half-degree mark. The question is when and if that will happen. So what does the atmosphere think is going on, right? We have colder than normal water on the equator, and it's the equator that matters. Just 5 degrees south of the equator, we've blotched it in, or putting it into blocks. The Kelvin wave generation area in the far west Pacific, the Nino 1.2 region right up there along Ecuador, and then in between the Nino 3 and 4, or they just sort of mash them together, the Nino 3.4 region from that point on the equator south of California out to about the dateline. All right, so the Southern Oscillation Index is some sort of way to sort of gauge numerically what's happening in the atmosphere above the ocean, all right? So they take pressure in Darwin. There's a long-running history. I mean, going back like 150 years or more. Darwin versus Tahiti. Tahiti in the Pacific, Darwin roughly in the Indian Ocean. If pressure is higher than normal in Tahiti, the index is positive. If pressure is lower than normal over Tahiti relative to Darwin, the index goes negative. Today, minus 14.46. That's what we want to see, is negative values. That's synonymous with at least the active phase of the MJO, if not El Nino. When you have positive numbers, like what we had, look at all down here, that's pretty much synonymous with La Nina. Right now, trend moving a little bit negative, but this is a really noisy set of numbers. So you average it out over 30 days. Today's value, 2.47. Hey, that's pretty good. And look at this. It's not the absolute number, too. It's the trend. Well, we were up at 12.88, 13. There we go. Down to 2.47 in half a month. That's a pretty quick change. Last year at this time, we were at plus 19 at the peak of La Nina. This all sort of indicates that La Nina is fading. But then you take it out even further, the 90-day average. Okay, today's value, 7.12. Where were we? Well, we've been in the 9 to 10 range. Now all of a sudden we're diving down. Last year, at this roughly at this time, we were at plus 15 here. Again, indicating that La Nina is losing its grip. This is when you're supposed to be in the peak of La Nina. We're nowhere near peak values, suggesting La Nina is definitely having a real struggle and not being very successful at holding on. We're thankful for that. Here's a 30-day SOI graphed out so you can see what's going on here. We go back to 2020. We were in a weak El Nino, and then as we hit July 2020, boom, the index starts rising. The downward spikes are the active phase of the MJO. The upward spikes are the inactive phase. During La Nina, the inactive phase dominates over the active phase, and your average goes high. Plus 21 here in January, right about the same time last year. And then back this summer, we tried to return to normal, but then here we go again. We started the upward climb, but notice, January, same time as last year, we were up at, this one says 21, it was 19, depends which index you use, there's a little bit of difference. But now we're down at 3 or something like that. Clearly, to me, suggestive of the depletion of the energy in the La Nina cycle. So finally, the forecast for sea surface temperatures from the CFS version 2 model in the Nino 3.4 region. All right, so here's 0 degrees. We want to see positive numbers if we're moving towards El Nino. Well, let's see. Here's what has happened, the solid line. Here's January, mid-January. So right now at -1 degrees. The forecast says temperatures rising a little bit, but still, this is a little bit troubling. They're just noodling around somewhere at -0.75, 3/4 of a degree into October. Next fall, this seems kind of hard to believe. This would suggest a 3-year La Nina. Now, I'm not a climatologist. There are some people that frequent our message portion of the YouTube channel, and maybe they have some thoughts on when the last time was we had a 3-year La Nina, if ever. But I suspect this is a little bit not quite right. This model, of course, again, we're going out many months. I suspect we're probably going to end up somewhere around ½ a degree or something like that, maybe a 1/4 of a degree below normal. But we'll see. The PDF corrected version is saying the exact same thing, maybe 0.6 to 0.7 of a degree below normal. So not particularly encouraging here for next fall. But again, I'm not going to put too much stock in this much yet. Let's get to July, and then we can have the debate. All right, so the good news is right now we're in a little bit of a lull for a day or two, but a gale is developing in the West Pacific. Another stronger gale is forecast behind that, and yet another gale is forecast behind that, ultimately resulting in a couple of swells pushing mainly towards Hawaii, but I think pretty good energy towards the U.S. West Coast. Beyond that, that'll get us to maybe 2 weeks from now, something like that. But beyond that, looks like the inactive phase of the MJO, or at least a neutral MJO, is going to set up. The jet stream will probably split, retrograde back. We're hoping at least to the dateline. The storm machine will probably fall apart, and the swell will disappear. The good news is we are hoping, and this is purely hope, no empirical data to support it, or at least nothing believable, is that we'll go back into the backdoor trough sort of scenario. The jet stream will start falling down the U.S. West Coast, and then we'll get precip and snow. So if you can't surf, well, at least you can ski or board or whatever you like to do, and maybe that would be a good thing for a while, till the next active phase of the MJO sets up somewhere around late February or early March, and then maybe we'll be into another little run of surf, probably not huge or anything, but some surf. I mean, we knew this was going to be a La Nina year. We knew it was not going to be great for surf, and it has lived up to that expectation in spades. But the good news is there has been some surf, and if you follow the videos, you've been tracking everything, you can make use of it when it's here, but you got to be nimble and you got to be quick and you got to be on it because it's here one day, gone the next. Now I'm looking beyond into summer. Well, Southern Hemi years don't do particularly well during La Nina years, and there's a lot of pent-up La Nina energy or lack of energy in the jet stream, and we don't expect this summer is going to be particularly great. The real issue is then, well, what happens next fall? Well, you just saw the forecast for sea surface temperatures. They don't look particularly promising, but I think it's it's 9 months to a year out. Probably a little bit too early to get too locked into believing a negative forecast this far out. So we'll remain cautiously optimistic. All right. If you enjoyed the video, give us a thumbs up. There we go. If you have comments, questions, post them on the YouTube channel there, and we'll be happy to answer them. If you haven't subscribed, please subscribe. All the data you see tonight came from Stormsurf.com. Go to the website, check it out. Links to the video will be posted on the top of every page of the website as soon as we get this thing produced and pushed out sometime pretty quickly. And then you can follow along during the week. Follow the buoys, follow the wave models, weather models, all that kind of stuff. Build your own personal forecast, and then check your knowledge against the video next week. And yes, next week we will do the video next Sunday. So that's it for this week. We'll do this again next week. Same time, same channel. Thanks for watching.